All right, so question number 5 is next. Now that we've worked a few of these unit conversion problems, I guess we can say that we'll up our game a little bit and we'll work one that's at least a little bit more difficult. But I aim to show how we can use the exact same systematic approach to get at the answer that we want. So let's go through this one. So it's a mass of a sample. It's 550 milligrams. I'm going to write that right down here right away. It's a little m, g, milligrams. It's the little m, the small one, not the mega. The mega is 10 to the 6, but this is milli, which will be 10 to the minus 3. So I write that down. That's what I know. 550 milligrams mg. Which of the following will express that mass in kilograms? So we have a series of choices. I'm not listing them here. I'm just working the problem. But we need to get to kilograms. So that is our desired unit. So we go through the normal protocol. We write the number that we know, and we're going to multiply it by a conversion factor. Now, you could, if you want to, if you're fancy, convert between milligrams and kilograms directly. So we would put our undesirable unit down here such that it cancels out. We're always going to do that. And if you're able on your own to generate the conversion factor between these two quantities, you could, in one step, make this conversion. All right. And it turns out that a kilogram is 1,000 grams. Okay. So 1 kilogram is 1,000 grams, but it's 1,000,000 milligrams. So that would work, and you could make this conversion happen, all right, in one step. Now, sometimes students are good with that, and if you are and you feel comfortable with doing that and getting the right answer, hey, go for it, okay? But in other cases, people aren't as fluid with these metric prefixes, and they like to revert back to this table that I'm showing, this table 1.3. And if that's you, you're not feeling quite as confident, you understand this idea of using the conversion factor, you understand that coupled with this table, well, then I'm going to work it a different way. And it's going to be a two-step method that will essentially achieve the same thing, okay? Now, if I'm going to work it the different way, the approach is going to be that we're going to convert back to our base unit. This is basically right here. Now, in this case, that's going to be grams. So in my first calculation, I'm going to ditch my undesirable milligram unit. So I put that down at the bottom and I convert back to my base unit, grams, or G, okay? Now what's the advantage of this? Well, the advantage is that this table, and if you get comfortable with it, you're going to start using these numbers out here in this row for the conversion factor. So this table basically gives you that information. Now again, you're not going to have that on the exam, so you're going to either memorize it or just develop some fluidness with these conversions, okay? But if you're one to not have a lot of confidence in this, what you can always do is convert back to the base unit first, and then in a second step, convert from the base unit to whatever unit you want to end up in, all right? And that's going to be our approach here. So I'm going to convert from milligrams to grams first, and then grams to kilograms to make a long story short. Okay, so how in the world can I do that? Well, I can use this conversion factor that's given to me in the table. And I can say that 1 milligram is equal to 1 times 10 to the minus 3 grams. And if I do that, 550 milligrams ends up being 0.550 grams. You just have to move the decimal spot 3 spaces, basically. 0.550 grams is 550 milligrams. They're physically equivalent. Now that is not our desired answer here, is it? Because it's got the wrong units. We've got 0.550 grams of material. Now we need to convert that into our desired unit of kilograms. It's our final desired unit, right? So since it's our desired unit, it goes up top. And our undesirable is now grams, so that they cancel. Now all we need to know is the relationship between grams and kilograms. Can this magic table 1.3 tell us that? And indeed it can. If we look up here, we find the kilo prefix. It's the lowercase k, highlighted all of that row in blue here, okay? And the conversion factor tells us that 1 kilogram is equal to 1 times 10 to the third grams. So I can write that in here, can't I? 1 kilogram is equal to 1 times 10 to the third grams. Well, that's what, 1,000, right? If I put the decimal spot right there, move it once, twice, 3 times, that's 10 to the third. So 1,000 grams equal a kilogram. So we basically just plug into the fraction and solve. And it's as easy as that. So we have 0.55 divided by 1,000. And when we do the math on that, we get 0.00055 kilograms. If I want to, I could write that 5.5 times 10 to the minus 4 kilograms. Those are basically the same numbers, aren't they? Right? Because to get to the scientific notation, you had to move the decimal 1, 2, 3, 4 places to the right. So both of these would suffice as an acceptable answer for this particular problem. And what was special about this problem? What was new? Well, here, we had to convert between 2 units of measure with prefixes that were not our base units. In the previous problems, we went back to the base unit. Okay, so that was a little bit different. And again, you know, there are multiple ways to solve these problems and get at the right answer. And I don't want to force you to do something that's not as efficient for you. So if you're really good at this already, and you've developed this skill and can get the correct answer every time, hey, do it the way that you do it, that you learned it and it works for you, okay? But for someone that really struggles with these unit conversions, you can always convert back to the base unit first, and then from the base unit to the desired unit. There's nothing really wrong with that. It's just more steps, okay? And some students I know just from experience feel a lot more comfortable with that. And you know, that's okay too. We don't all need to use the same method to get at the right answer. As long as we get to the right answer, we can be happy with that, okay? So that's this one.